Hello everyone, welcome to 1000 Math 7. This is the video for solving exercise 1.1. Okay, this is the first exercise of the chapter sets. So I've done the first video, the theory before this exercise 1.1. So please make sure to watch that before you start watching this video. Okay, alright, let's go ahead and try to solve this exercise. And the question number 1 is, which of the following are sets? It's asking amongst this 9 that statement, like there are some statements that has been given. You need to decide if it is a set or not, and you also need to justify your answer. Okay, so let's look at the first one. The first one says the collection of all months of a year. Okay, all the month. How many months are there in a year? There are 12 months, right? 12 months are January, February, March, April, May, June, July, August, September, October, November, and December. Right? These are the 12 months that we have in a year. Okay, the collection of all the months of a year beginning with the letter J. So it says that all the months that begins with the letter J. So January is one such month that begins with the letter J. June is one such month that begins with the letter J, and July is one such month which begins with the letter J. And there is no other month that begins with the letter J. So if you try to form this collection, January, then June, and then July, okay, this is a collection of what? Each of the element has a common nature, that it's a month of a year, and it begins with the letter J. So this collection is well defined, right? We can properly define this collection. So this collection is eligible to become a set. So this is a set. Why? Because this is well defined. Whenever someone says that, tell me the, like if you ask a question to your friend, tell me which are the month in a year which begins with the letter J. So his answer will also be the same, January, June and July. Your answer will also be the same, or my answer will also be the same. So there is no contradiction here. So this is well defined. Now let's look at the next one. The collection of 10 most talented writers in India. Now tell me, if you try to write the collection of 10 most talented writers, okay, let's say according to you, Chetan Bhagat is the most talented writer, but it's not according to me. Okay, so whatever collection of 10 writers that you try to form, okay, that you try to write, that may be best according to you, but according to me it may be different, because it says write the collection of 10 most talented. This word most talented can be different for you, because the parameter for defining talent, like a writer that you like most, he writes all the fiction, okay, but I don't love fiction, so I'll have no writer that writes a fiction in my list. So it depends. So the collection of 10 most talented, this word most talented is not well defined. We cannot say which is the most talented, or there is no fixed way to determine, okay, this is the most talented, or for this reason. We cannot say that. Okay, so this is why this collection, whatever set of writers you form, 10 names of writers, that will not be a set, because the 10 names that you will form, the 10 names that I will form may not match. The 10 names your friend will form may not match. Okay, so this is not a set. Let's look at the next one. A team of 11 best cricket batsmen in the world. Once again, say best. Best. Can you say who is the best cricket batsman? Nowadays, we'll say Virat Kohli. But according to me, if I try to form, if you know a cricket match, okay, there are two teams that plays the cricket match, and each of the team has 11 players, and they fight against each other and try to win the match. So if I try to form a team of 11 players, I can include 11 players of my choice. If you try to form the team of 11 players, you will include the 11 players of your choice, right? So your choice can be different and my choice can be different. Like your choice may include Joe Root, your choice may include Steven Smith or David Warner, all the foreign players, and my choice will, let's say, include all the Indian players. So obviously, right, that is the best cricket, the list that you will form will be best according to you, but includes all the foreign players. And if I form a set that is best according to me, but I have included all the Indian players, so there is a contradiction. Whoever forms a set, it depends on the person as to what is best according to him. So this best is not well defined. Okay, so this is not a set. Now the collection of all boys in your class. Think about a class. Okay, this is your classroom. Let's say all of you sit in this way. Okay, your teacher has a blackboard here and he teaches you from this point on. Now there are some boys and there are some girls, right? You can count how many boys are there and then write all the names of boys in this curly brackets. That means the collection of all the names of the boys is fixed. Yes, these are the boys that is in class 11. You can say there will be no contradiction. So this collection of boys in your class, or let's say class 11, is a set. Okay, this is a set. The collection of all natural numbers less than 100. If you know about natural numbers start from 1, 2, 3, 4, 5, 6, 7, and it goes on as long as you want to write. So when you write in this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you go up till, let's say, 99, and then you get 100. So the collection of 1, 2, 3, 4, 5, and then up till 99, because it says less than 100. This is a collection of what? Numbers, 99 numbers, which is what? Properly defined. Whenever someone says natural numbers less than 100, it will be this only. If you ask the same question to your friend, same answer. Ask it to someone else, you'll get the same answer. So there is no contradiction. So this is a set. This is well defined. Each of the element is what? A natural number, and this less than 100. 4 is a natural number less than 100. If you talk about 50, is a natural number less than 100. So the condition is what? That the collection should have numbers that is a natural number, and also it's less than 100. Okay, so this collection is well defined. Now a collection of novels written by, novels means books, okay, written by the writer Munshi Premchand. Okay, Munshi Premchand is a writer. He may have written a certain amount of books, right? I'm not sure exactly how many books he has written, but let's say he has written down 50 books. So you can write the names of all the books together. Like the first book, let's say it's the name is A, then B, then C, then D, all these books. You can write all the names. And these are all the books that has been written by specifically Munshi Premchand, right? So this collection, each of the book has what? A nature, that it is a novel and it is written by Munshi Premchand. So this is a well-defined collection. Okay, so this is a set. This collection becomes a set. Always remember that we have learned in the video lecture also, in the first lecture, I'm sorry. So set means what? First, it has to be a collection of objects or elements, and that collection should be well defined. There should be no contradiction, and there should be just one answer. Okay, the collection of all even integers. Okay, even integers. If you know what is integers, try to recall the number line. There is a 0 at the center. On the left hand side you have all the negative numbers and so on, and in this, on the right hand side you have all the positive integers, like this. Okay, so here if you see the collection of all even integers, -2 is an even integer, 2 is an even integer, then 4, then here you'll get -4. So the collection is what? Like this, -4, then you have -2, then you have 2, then you have 4, then you have like this. So this is a well-defined collection, that each of the element that you write in this set, there will be a lot of numbers. Okay, you can keep on writing as long as you want to write, on the left or on the right, but each of the element is well defined. That 4 is what? An even integer, and 4 is an even integer. Simply there is just one condition. 2 is an even number and is also integer. -4 is an even number, is also an integer. So this is a set, because this collection is well defined. Each of the element has a common definition. The collection of questions in this chapter. Okay, in this chapter there are some questions, right? If you count how many questions are there, let's say you have 100 questions in this chapter, so you can form a collection of these 100 questions, right? A collection of these 100 questions, and each of the question in this chapter has a common nature. That let's say you have 100 questions in this way, 1, 2, 3, question number 1, question number 2, 3, then question number 4. In this way you have question number 100. So question number 1, if you talk about question number 1 or question number 2 or question number 3, each of this question is a question of this chapter only. Okay, so this is well defined. Each has a common nature. Question number 100 is a question of this chapter. Okay, question number 99 is a question of this chapter. So this is a set, or this collection of questions in this chapter is a set. The next one, the collection of most dangerous animals in the world. Now tell me, tiger is a dangerous animal, right? Like if you face a tiger, it's most probably that you'll get killed. So tiger may kill you. So in that way you can say the tiger is a dangerous animal. But tiger may not also kill you. He may be kind to you. But if you think about a mosquito, he will come and bite you, and if he carries some kind of like viruses, then you may get infected by the virus and you may die. So you cannot say exactly which is the most dangerous animal. Okay, dangerous animal for you, if you try to form a collection. Okay, let's say you form a collection of 5 animals that is most dangerous, A, B, C, D and E. Let's say this is the 5 animals that is most dangerous according to you, but it may not be dangerous according to me. my list may include F, G, H, I and J. Okay, like your list has a tiger, your list has a snake, your list has a lion, but my list may have a cat, or my list may have a what? My list may have a, let's say, a dog. A dog can also kill you, right? So this is not well defined. Why? Because this term, most dangerous, what is most dangerous? It can be different for you, it can be different for me. Okay, so I hope this is clear to all of you. Just remember that a collection, see here, all this is has used the word collection, 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 collection. So a set means it has to be a collection of some objects. It can be books, it can be people, it can be money, it can be tables, it can be chairs, it can be anything. Okay, it should be a collection, and each of the element in that collection should have one common nature. Okay, only then it will be a set. Now let's move on to the next question here. The next question says, let A is equal to, this is a set, see, this has been enclosed within the curly brackets, each of the element has been separated by a comma, and the name of the set is in capital letters. So this is in the roster form, right? This is in the roster form. Okay, we have learned two ways of representing a set. One is known as the roster form, the second one is known as the set builder form. The roster form is also called as the tabular form. Here it says insert appropriate symbols, this and this means epsilon. I've told you in the lecture video, this means belongs to and this means does not belong to. Now insert the symbols in the blank spaces. So how to put the symbol in this blank space? Will it be this or this? Let's see here. 5 space A. So 5, check if 5 is an element of A or not. The set A has 1, 2, 3, 4, 5 and 6. Yes, it has the 5. So 5 belongs to the set A. 8 is not there, so 8 does not belong to the set A. 0 is not there, so 0 does not belong to the set A. 4 is there, so 4 belongs to the set A. 7, it's not there, so it does not belong to the set A. And 10, it's not there in this set. Okay, based on this set, so it does not belong to the set A. So I hope this is clear to all of you. Now let's move on to the next question. Here it says write the following set in roster form. Okay, each of them has been given in the set builder form. See, x such that, x such that. Now before we do this, okay, let me give you a brief recap of what is a set builder form. In the set builder form, if like, okay, you know that set is what? A collection of objects, right? A collection of objects, and each of the object has a common nature that I've told you. So in the set builder form, we write the common nature of each of the element, and while doing that, we assume each element of the set to be x, and we define this x. See here, x such that, okay, this x will be defined now. X is an integer and this is a condition. Okay, so this is how we write a set in the set builder form. So here we are supposed to write in the roster form, means we need to write A is equal to then all the elements according to this statement. Okay, so each of the element has been assumed to be x. So the first element, let's try to get the first element. X is an integer. You know what is in integers? This is the line of integers, like the solid numbers, all the positive, negative and 0. So x is an integer and this is a condition. Okay, now don't get confused with this kind of a condition. Okay, if I try to explain you this says x is greater than or equal to -3 and less than 7. So if you see here in the number line, this is 0, this is 1, this is 2, this is 3, 4, 5, 6 and 7 and so on. On the left hand side, -1, -2, -3, then you got -4. So it says x is greater than or equal to -3, so -3 point is included. Greater than -3, this is -2, because -4 is less than -3. When you go to the left hand side of 0, the value goes on decreasing. Although you may say that 4 is bigger than 3, but -4 is smaller than 3. Here 4 is bigger than 3. Okay, so as you move to the right hand side, the value goes on increasing. As you move to the left hand side, it goes on decreasing. X is greater than or equal to -3, so x can be what? -3, because equal sign is there, so we'll include -3. Then you have -2, then you have -1, 0, 1, 2, 3, 4, 5, 6, but not 7, because there is no equal sign here, so we'll not include 7. It should be less than 7. So these are the numbers from -3 to 6. So if you go back here, x is an integer. We have seen this on the integer line itself. Okay, so and the condition we have checked it. So the first element is -3, then you have -2, then you have -1, then you have 0, then you have 1, 2, 3, 4, 5, 6. This is the set. Now if you cross check it, each of the element, as I told you before, each of the elements should have a common nature. If you see here, -3 is an integer, this was the first condition, and -3, it lies according to this condition. Okay, if -3 is x, assumed to be x for some time, then this x is equal to -3. Okay, this is equal. If you talk about -2, if x is -2 for some time, then -2 is an integer, right? And -2, it lies between these limits, right? If you talk about 3, 3 is an integer and it lies between this -3 and 7, right? So each of the element has satisfied both the conditions. Now let's talk about the second one. B is equal to x such that x is a natural number. You know the natural numbers, they start from 1, 2, 3 and goes on, and less than 6. Okay, this is very simple. Open the curly bracket. The first element will be what? The first natural number 1, then 2, then 3, then 4, then 5. And it says less than 6, so I'll not include 6. I'll just write up till 5 and close the curly bracket. This is your answer. This was very simple. Okay, now let's look at the next one. C is equal to x such that x is a 2-digit natural number. Okay, it's now talking about 2-digit numbers. So let's try to have a brief knowledge about this. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that it goes on. So after 9 you get 10, and 10 is the first 2-digit number. Then you get 11, then you get 12. These are all 2-digit numbers, right? Then you get 13 and so on. It goes on up till what? 98 and then 99. Because right next to 99 you'll get 100, and 100 is a 1, 2, 3, 3-digit number. Okay, so we'll consider this part. Let's see now. X is a 2-digit natural number, so we have the list of 2-digit natural numbers such that the sum of its digits is 8. Sum of its digits. Take the first natural number, first 2-digit natural number, 10. What are the digits in it? 1 and 0. If you add it, 1 plus 0 will give you just 1. The next one, 1 plus 1 will give you 2. But it says it should be 8. So if you check in this way all the numbers, then the set C will be what? The first natural number, the first 2-digit natural number, I'm sorry, that is also giving the sum of its digits as 8 is what? 1, 7, 17, because 1 plus 7 will give you what? 8. Then you have 2, 6, then you have 3, 5, okay, then you have what? 4, 4, then you have 5, 3, then you have means 53, okay, then you have 62, then you have 71, then you have 80 is also, because if you see 8 and 0, if you add both the digits, it's 8 and it's a 2-digit number. So this is your answer if you check each and every 2-digit number in this way. Okay, this is very easy. Once you do it for 2 to 3 times, this will give you the basic idea that let me write a number in which the digits can be added up to be 8. If this gives you 10, then what? Let's say instead of 8 you have 10. So x is a 2-digit natural number such that the sum of its digits is 10. So if it says 10, then what I'll write? I'll write the first number as 5, 5. Okay, then 4, 6. Okay, then I'll write okay, let's start from the very basic. Let's start 1, 9, right? 1, 9 will give you what? Plus will give you 10. Then 2, 8. Then I'll have 3, 7, then I'll have 4, 6, then I'll have 5, 5, then I'll have 6, 4, then I'll have 7, 3, then I'll have 8, 2, then I'll have 9, 1. Okay, this will be the set of numbers if this is 10 instead of 8. Okay, so the basic idea I've given you. Now let's move on to the next one. D is equal to x such that x is a prime number. I hope that all of you know the prime numbers. Prime numbers are what? 2, 3, 5, 7, 11 and so on. And what is the definition of a prime number? Prime number is such a number that is divisible, that gets divided, I mean, by itself and by 1. There are only 2 numbers that divides a prime number. So if you check 5, is there any number that divides 5? Yes, 1 will divide 5 times, and 5 will divide 5 one time, and there is no other number. Similarly 11 or 7 or any other prime number. And the only even prime number is 2. There is no other even number that is also a prime number. Okay, rest all of them are odd. So the only even prime number is 2. So this is the basic idea of a prime number. So here it says x means the set D will have some elements where each of the element is a what? X is a, each of the element is supposed to be x, right? So x is a prime number which is divisor of 60, means it's a prime number that divides 60. So let's check the first prime number, 2. 2 will divide 60, yes. Next is 3. 3 will divide 60. Then 5 will divide 60. Okay, 2, 3, 5 will divide 60. 7 will not divide 60. 11 will not divide 60. Next, you'll get 13 will not divide 60. So these are the only 3 prime numbers, 2, 3 and 5, that divide 60. Now if you cross check it, each of the element, see here 2, 3 or 5 is a prime number. This was the first condition. Which is divisor of 60? Yes, 2, 3 and 5 divide 60. So both the conditions are fulfilled. In that way we write the elements. Now the next one, the set of all letters in the word trigonometry. I think this is very easy. Okay, E is equal to, I need to write the set of letters in this word, and while doing that I need to make sure that I do not repeat any of the letters. Okay, so in the word trigonometry, T is there one time. Let's check if there is another T. Yes, 2 times, so I'll just include 1 T. Then R is there 2 times. See, I'll just include 1 R. Then I is there just 1 time. Okay, just 1 I. Then G is there just 1 time, so I'll write G. Then O is there 2 times, I'll just write 1 O. N is just 1 time. M is just 1 time. E is just 1 time. And then Y at last. Okay, so this is the set of what? Letters in this word trigonometry. While writing such a set, do not make a mistake to repeat the letters. Okay, in the roster form we are not supposed to repeat any letter. Okay, now next, F is equal to the set of all letters in the word better. So F is equal to what? I need to write the letters that I can see here, and while writing those letters in the roster form I cannot repeat the letters. So the first letter is B. Is there any B? No. B. E, there is 2 E, so I'll write just 1 E. There is T 2 times, so I'll write just 1 T. And R, I'll write just 1 R. So this is the set. This is the answer. Let's look at the next question. Question number 4. Write the following set in set builder form. Okay, so I've told you that while we write a set in the set builder form, we check the common nature of each of the elements. See, here it was written in the set builder form. So from the roster form, how can I get this? See, 2, 3 and 5, it's a prime number and it's a divisor of 60. So for this set, what can I write? X, I'll assume each element to be X for some time, so X can be 2 or X can be 3 or X can be 5. And X has a common nature that X is a prime number and a divisor of 60. So I write the common nature here. Similarly, here try to find something common. See here, 3, you have 6, then 9 and 12. Try to observe carefully. This is just 3, so I can write 3 into 1. This is 6, I can write 3 into 2. This is 9, I can write 3 into 3. This is what? 12, I can write 3 into 4. So if you look carefully, 3 into 1, 3 into 2, 3 into 3, 3 into 4 means this is a set in which each of the element is like 3 n, and n is what? 1, 2, 3, 4. When n is 1, then I get this. When n is 2, I get this. When n is 3, I get this. And when n is 4, then I get this. So what can I write in the set builder form? Let's say this is a set A. Okay, let's take it to be A. This is B, this is C, this is D, and this is E. Let's say this way. X, each of the element I have assumed to be X. X such that, what is X now? What is the nature of each element? X is equal to 3n, where n lies between what? This n lies between 1 and 4. I've given the equal sign also so that you include 1 and include 4 also. Okay, so this is your answer. Now the next one, try to look for a common nature. 2, 4, 8, 16, 32. See, it's 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, right? Because 2 to the power 3 means 2 into 2 into 2. 2 2 is a 4, 4 2 is a 8. So this is the way it goes. So the common nature is that the base is 2 always, and the power starts from 1 and goes up till 5. So if I put n, what I'll say n to be? N is equal to 1 or 2 or 3 or 4 or 5. Or I can say n lies between what? 1 and 5. So to write this in the set builder form, I'll say B is equal to X such that X is equal to, what is the common nature of each X? X is what? 2 to the power n, where n lies between 1 and 5. This is the way I can write in the set builder form. Okay, now let's look at the next one. 525, 125 and 625. So this is also quite same. So this is what? 5 to the power 1, 5 to the power 2, because 5 square, 5 into 5 is 25. Similarly, 5 to the power 3 is 125, 5 to the power 4 is 625, right? So here also, each of the element, if I suppose, if I see here, each of the element has a common nature. The base is 5 always, and the power keeps on changing, 1, 2, 3 and 4. So if I write the power to be n, then what? N will lie between 1 and 4. So I can define this set as, the set C is equal to x such that, I've assumed each to be x. And what is the nature of each x? That x is equal to 5 to the power n, where n will lie between 1 and 4. So whenever n takes 1, I get the first element. Whenever n takes the value 2, because this means that n can be what? 1, 2, 3 or 4. So when n is 1, I get this. When n is 2, I get this. When n is 3, I get this. When n is 4, I get this. So this is your answer. Okay. Next one. This is 2, 4, 6 and so on. So this is very simple, right? 2 is an even number. The next even number is 4. So I can write what? This is a set D. D is equal to x such that x is an even number, right? All these are even number and a natural number. Natural number. This is correct, okay? Or you can simply write x is an even natural number. I've just broken it down. The first condition is that the elements here, see, all of them are even, so all of them are even. And these are also natural numbers, so I'll include natural numbers, okay? The last one, 1, 4, 9, 100 till 100, okay? So this is what? It seems like some kind of a square. This is 1 square, this is 2 square, this is 3 square, and so on. This is what? 10 square. So the power is 2 all the time, see? Square, 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 square. But the base, it changes. 1, 2, 3, up till it goes to 10. So what is the element? What can you, or in what way can you represent? You can represent it in n to the power 2 or n square, where n is what? N lies between 1 and 10. When n will take the value 1, you'll get 1. When n becomes 2, it will be 2 square, 4. That is the second element. When n is 3, then 3 square. 3 square is 9, the third element. So in this way. So to write the set E is equal to x such that x is equal to what? N square, where n lies between 1 and 10. The final value that n takes is 10. Okay, this is 10 square. So whenever n is 10, 10 square, that is 100. So I hope this is clear to all of you. Now let's move on to the next question here, the question number 5. List all the elements of the following sets. Okay, we need to write the elements of the sets. So there are 6 sets and all of them has been given in the set builder form, x such that, x such that, x such that. Okay, so let's look at the first one. A is equal to x such that x is an odd natural number. So there are two things here. See, in the set A, if I try to write it in the roster form, I'll write all the elements, right? And each of the element will have a common nature. So the common nature is that each of the element has been assumed to be x, and the common nature is that x is an odd, okay, it should be an odd number, and also a natural number. So the natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it goes on. So out of this, this is even, 2, 4, 6, 8, 10, 12, all these are even, and these are all odd, 1, 3, 5, 7, 9, these are all odd. So x is an odd natural number. So the first odd and also a natural number is what? 1, then I'll get 3, then I'll get 5, then I'll get 7, and so on. It will keep on going, right? So these are all the elements I've written down in the roster form, okay? Or if in exam, if you are just supposed to write the elements, then just write 1, 3, 5, 7. Do not include these brackets. If you include these brackets, then it means it's a set, okay? Now, the second one, this is the first one, okay? So this is done. The second one, B is equal to x. So once again, B, all the elements has, each of the element, has been assumed to be x. And what is the nature? That it's an integer. Okay, we know what is integers, all the negative numbers, 0, and all the positive numbers, solid numbers. And x, this is a condition. Okay, don't be scared of this condition. Let me just solve it down for you. 9 by 2. So 1 by 2 is what? Half, or 0.5 minus 0.5. I can write x. And 9 by 2 means 4.5. Try to divide it. Okay, 4.5. So it says x is an integer. Each of the element will be an integer. So obviously 0.5 is not an integer, 4.5 is not an integer. So they have not included this equal sign here. Okay, so if you see the number line, there is a 0 here, there is -1, -2, and so on. There is 1, there is 2, there is 3, there is 4, there is 5, and so on. Okay, now if you see here, 0.5, that to minus 0.5 will lie somewhere here, right, on the negative side of 0. Minus 0.5 here will be the point, and 4.5 is what, somewhere here, 4.5. So write down all the integers. X is the numbers between these two, so numbers between these 2 points. So what are the integers between these 2 points? The first integer is 0, then you have 1, then you have 2, then you have 3, 4. 5 will not be included because I am supposed to look up till this point. 4.5 will be somewhere between 4 and 5. So before this, because it says x is less than 4.5, so it should be x should be less than 4.5. If 4.5 is here, the less integer, the integer just before that 4.5 is 4. So these are all the elements. Let's look at the next one. X such that x is an int. So these are all the elements in this set. Okay, so don't get confused with such an expression. X such that x is an integer. Okay, I know the integers, and x square less than or equal to 4. So whatever x that I take, okay, C is a set where there are some x, there are some elements. So whatever element I take here, when I square that element, because it says x square, okay, so whenever I square that element, it should be less than or equal to 4. Okay, so if I take the integers, okay, let's say I take x to be 1. Okay, then x is 1, then x square is what? 1 square, that is 1, which is what? Less than 4, right? So I can take x to be 1. If I take x to be 2, then x square is what? 2 square. 2 square is 4, which is equal to 4. So this is also satisfying the condition. So I can take x to be 2. If I take x to be 3, then x square becomes what? 3 square, means 9, which is greater than 4. See, it should be less than 4. It cannot be greater than 4. So I cannot take x to be 3, because when I square it, I get 9, which is not satisfying the condition. Okay, so let's check for, since it's talking about integers, I've checked for the positive side. Okay, I'll check for 0 and for the negative side also. So if I take x to be 0, then x square is also 0. 0 square is 0, which is less than 4. Yes, the condition is good to go. If I take the negative number, -1, let's say, then x square minus 1 square will be what? -2 times minus into minus becomes plus. 1 square is 1, that is 1, which is less than 4. Yes, the condition is good. X is equal to -2, then x square becomes what? 4, which is equal to 4, and there is a equal condition for this also. So this is also good to go. Okay, this is good, this is good, and this is good. But if I take x equal to -3 on the left side, then -3 square will become what? X square will become 9, which is greater than 4. I cannot do that. This is the condition given. So the elements are what? This cannot be included. So the elements are what? -2, -1, 0, 1, and 2. Okay, these are the numbers. That is also integers. That is also satisfying this condition, that whenever I square this number, I get a number which is less than or equal to 4. Okay, now let's look at the next one here. D is equal to x such that x is a letter of the word loyal. Okay, Loyal. So if you try to form the set of letters in this word, how will you do it? L, there are 2 L, so I'll just write 1 L, then O, okay, there's 1 Y, then A. This is it. Okay, so the elements, okay, since it tells us to find the elements of the set, so elements of the set D are L, O, Y, and A, the set of letters in the word loyal. Now it says the next one, E is equal to x such that x is a month of a year not having 31 days. So in a year we have what? January, February, March, April, right? Then we have May, then we have June, then we have July, then we have August, then we have September, then we have November, then we have December, and then we have January, February, March, April, May, June, July, August, September, October, November, and then we have December. Okay, so these are the 12 months that we have in a year. Now this is a month of 31 days. 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 This is also a month of 31 days. This is a month of 31 days, and this is a month of 31 days, right? Alternate if you check it on your calendar. Okay, so I cannot include this, I cannot include this, and this, because here if you see x such that I need to write the set E where there will be some month, because it says x is a month of the year that does not have or not having 31 days. So the months are what? February. February does not have 31 days. Then you have April, then you have June, then you have September, and then you have November. So this is the elements 1, 2, 3, 4, 5. So there are 5 elements. I've written down in the roster form. Okay, 5 elements or the name of 5 month of a year. See here, February is a month of a year. Yes. April is a month of a year. June is a month of a year. So the first condition is true for all. And the second condition is that not having 31 days. February does not have 31 days. April does not have 31 days. June does not have 31 days. Or September or November does not have 31 days. Okay. Now, F. So this is the collection. Okay. 5 elements are there. Now, the next one, X such that X is a consonant in the English alphabet which precedes K. Alright, all of you know the English alphabets, right? There are 26 letters in the English alphabet, which is divided into 21, which are called as consonants, and 5 of them are vowels, right? So here it says there is a set F, in which there are some elements. Each of the element has been assumed to be X. So what is the nature of each X or each element? That it's a consonant. Okay, it's a consonant in the English alphabet. It should be a consonant. This is the first condition, and which precedes K. Precede means before K. Succeed means after K. Okay, so precede and succeed. 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 Precede and succeed. Precede means pre, means before. Succeed means after. Okay, so let us go ahead and write all the alphabets: A, B, C, D, E, F, G, H, I, J, and K. I'll not write K because it says which precedes K, that means before K. So these are the alphabets that we have before K. Now out of this, let us take out the vowels, because I should only include the consonants. And what are the vowels? Vowels are A, E, I, O, and U. So here A is a vowel, E is a vowel, and I is a vowel. So I excluded the vowels, and these are all the alphabets before, all the letters, before K. So what is the set F? The first element is B, then C, then D, then F, then G, then H, and finally J. Okay, so this is your answer. So here each of the element is a consonant, and each of the element is before K, or it precedes K. Okay. Now let's look at the next one, the last question, I think, this one of the first exercise. So match each of the set on the left. Okay, this is the left side, which is in roster form. All of them are in roster form, with the same set on the right, which is described in set builder form. So this is all that has been described. We need to match it. Like there are 4 of them here, 4 of them here. So try to match it. Let's do it. The first one, let's see here, 1, 2, 3, and 6. Okay, this is 1, this is 2, 3, and 6. What can you see here? 2 and 3 are prime numbers, but 6 is an even number. 2 is an even number. So let's check it on this side here. X such that X is a prime number. Okay, here 1 is not a prime number, so this I will exclude, leave it. X such that X is an odd natural number. Here 2 is even, 6 is even, so leave this. X such that X is a natural number. Okay, all of them are natural numbers, and divisor of 6. 1 will divide 6, yes. 2 will divide 6, yes, 3 times. 3 will divide 6, yes, 2 times. And 6 will also divide 6. So both the conditions, that X is a natural number, means each of the element we assume it to be X for some time, right? And we define the nature of each X. So each of the X, if X is 1, then X is what? A natural number. 1 is a natural number, and 1 is a divisor of 6. That means 1 divides 6. Let's take X to be 6 for some time. So if X is 6, then 6 is what? A natural number, and it also divides 6. So this is the combination. Now 2, 3. Here it says X such that X is a prime number. 2 and 3 both are prime numbers. Okay, this condition is fulfilled. And a divisor of 6. Yes, both 2 and 3 will divide 6. This is very simple. Okay. Now the next is MATH. Okay, this is something mathematics. Okay, this is the combination. Why? Because the word mathematics, if you try to write the set of letters, okay, because here it says X such that X is a letter of the word mathematics. So this is a word, and if you try to write the set of letters in this word mathematics, what will you do? You'll first include M. Since M is 2 times, so I'll just include 1 M. Then you'll include A. A is 2 times, so I'll just include 1 A. Then T. T is also 2 times, I'll include 1 T. Then H is 1 time. Then E is just 1 time. And I, and then C, and then S. So this is what you have here. So this is what each of them. M is what? A letter of the word. Yes, this is a letter. A is a letter of the word mathematics. Yes. T is a letter of the word. And while writing this set, they have not repeated any of the elements. Okay, like M, A, and T was repeated in the word mathematics, but while writing the set, we do not repeat any of the elements. And this is a rule that I've taught you in the video lecture, that while writing a set in the roster form, make sure not to include, or sorry, make sure not to repeat any element. Okay, now the last one, obviously this will go to the number B. Let's see how. 1, 3, 5, 7, and 9. Since yeah, this is odd number, 1, 3, 5, 7, 9. Okay, here it says x such that, okay, each of the element is what? Is an odd natural number less than 10. Okay, it should be a odd natural number. Yes, all of them are odd, right? 1 is odd, 3 is odd, 5 is odd, 7 is odd, 9 is also odd, and it's less than 10, because right next to 9 you'll get 10. So these are all odd natural number and it's less than 10. So this is how we match. Alright, this is it for today. So this is the complete exercise 1.1, and if you have any questions, do make sure to post it in the comment section below, and I'll try to answer them as soon as possible. And thank you so much for watching. We'll meet in the next video.